The views and opinions expressed in this program do not necessarily represent those of Natural Bridges Media or KSQD's staff, volunteers, or underwriters.
Hello and welcome to Talk of the Bay. I'm your host, Len Bier, and with me today is Professor Rebecca Braslau. Rebecca Braslau has served on the faculty at UC Santa Cruz since 1991, where she is a professor of chemistry. She has a BA from Reed College, a Ph.D. in chemistry from the University of Wisconsin, and carried out postdoctoral studies with Bernd Giese at Universitat Basel, the oldest university in Switzerland. She has been a visiting professor at other universities, including in Bangkok, Thailand, Galway, Ireland, Melbourne, Australia, Eindhoven, the Netherlands, and Paris, France. In 2014, she earned the Excellence in Teaching Award at UC Santa Cruz. Professor Braslau is the director of the Braslau Lab at UC Santa Cruz. The Braslau Lab is a synthetic organic chemistry group currently focused on material science projects. Given the crisis of persistent plastics in our environment, researchers are currently focused on developing methodologies to chemically upcycle post-consumer waste PVC. Over the past decade, they have focused on developing non-migratory internal plasticizers to replace phthalates, a pervasive class of endocrine-disrupting compounds. Rebecca Braslau, welcome to Talk of the Bay.
Thanks so much. I'm quite happy to be here.
You're an organic chemist. I got as far as learning the chemistry of combustion for fossil fuels, and that was about it. Since you're doing a lot of research on plastics, could you give us a quick introduction to the composition of plastics and why it's important to understand these materials and how they break down?
Sure. So plastics, the word actually comes from plastikos, which is a Greek word which means moldable. And they're long linear chains, predominantly linear chains of organic carbon molecules, carbon-based molecules. Some of them have, all of them have a hydrogen and carbon, but some of them also have oxygens and nitrogens or chlorines or other elements in them. The ones that have all carbon chain are particularly difficult to break down, and that's a subclass of about half of them because nature doesn't know any type of molecule that is more than about 40 or 45 carbons in a single chain in a line and doesn't have any enzymes for breaking those down. And so when we get polymers, oftentimes they're hundreds of thousands of long carbon chains, and they persist in the environment because there really isn't any type of mechanisms for them to break down naturally, and so that's why we have a plastics problem.
Wow, that's to think of it in terms of hundreds or even thousands relative to less than 45. That's a really different compound than existed prior to human synthesis of these compounds. So what kind of problems does all this plastic manufacturing and then plastic waste present?
Well, the biggest problem is that there really is an accumulation of plastics, and there's really not good ways to get rid of them. Some of the polymers, some of the plastics can be pretty readily recycled if they're collected cleanly, like polyethylene terephthalate, which is used in water bottles. Those are actually quite well recycled if they have a clean stream of them. And for example, at military bases where they use a lot of water bottles, or even I was traveling in Peru recently and I saw big containers where people were throwing their water bottles in multiple cities as we were going around in a bus, and they were collecting PET water bottles for recycling. Those have oxygens in the chain and can be broken down pretty easily. But the ones that are all carbon chains are more challenging, and unfortunately most of them end up in the landfill, and a lot of them escape into the environment, sometimes from the landfill. And all of those eventually turn into microplastics and nanoplastics, and those become entrained in the air, They're in the soil, and they end up, a lot of them, in the water, and there's really no way for us to deal with those.
I had read that about 22% of global plastics just end up in the environment. That is, they never even see a landfill, and less than 2% are recycled. So that's a pretty pathetic number if you think recycling is going to get you anywhere. And, to that point, we've learned that most plastics, as you mentioned, are really difficult or impossible to recycle in any conventional sense of that. So how has the research you're doing taken a different approach to how we deal with plastics that would otherwise, contain or break down into compounds that have negative health impacts?
So I'm an organic chemist, a synthetic organic chemist, and so of course I'm going to approach this problem as an organic chemist, and I look at this and say, how can I break a carbon-carbon chain? That's really, or carbon-carbon bond. That's really what we focused on. And I put together a grant proposal and thought about how to do this, and came up with a very expensive metal catalyst that could break down carbon-carbon double bonds. And we did a preliminary project on this, and it works a little bit. It probably could use some enhancement, but the truth is no one's ever going to use a very expensive metal catalyst to break down junk plastic. And so we really need very inexpensive ways to do this. And so we changed gears, and we're now focusing on using much more less sophisticated and much more inexpensive reagents to try to do this. And in my lab, we really have our eyes on polyvinyl chloride. PVC is the third largest plastic being produced in the world right now, and there's essentially zero recycling of it. I should say that a lot of plastics, what a lot of municipalities are doing is they're incinerating it. Yeah. And that turns the plastic at least into energy, but it also releases a lot of greenhouse gases. But PVC is special in that when you incinerate it, it creates a lot of hydrogen chloride, HCl gas, and that disintegrates the incineration equipment. And it also produces some very, very, very toxic compounds with chlorines on aromatic compounds, just very, very toxic, small amounts, but lots, very highly toxic compounds. And so we don't really want to incinerate PVC at all. So they try to remove all the PVC, and then they incinerate it, and then they add to greenhouse gases. So that's another very common way that municipalities are dealing with plastic, because recycling is actually very challenging. There's a few plastics like polyethylene that can be recycled, but it's always downcycled. So each batch, every time you recycle it, you get an inferior product, and it ends up becoming like park benches or asphalt or things like that.
Right. Yeah, which is true of paper too. You have to go to a lower and lower grade paper as you recycle the fiber. When you say PVC polyvinyl chloride, a lot of people may not have paid a lot of attention to this, but I know we use PVC in water piping. We use it in window frames. You see it in furniture, particularly outdoor furniture, but all kinds of stuff. And also, nowadays you'll see it in car parts.
PVC itself is relatively not toxic, but when you start to incinerate it and things like that, that's when the toxic compounds can get formed at high temperatures.
Breaks down.
Yeah. What PVC does have that's quite toxic are plasticizers, which are the most common one. Diethylhexyl phthalate is an endocrine disruptor. And so there's a lot of that in PVC as well.
And that's still being used as?
It is. It's outlawed for childcare articles and infant care things, but it's used in floor tiling and rubber duckies and rubber bands and all sorts of common household goods.
Wow.
Yeah.
Okay. So when in your research, you're trying to find alternatives to this stuff, right?
Well, so we spent about 10 years developing 3 different strategies for getting rid of plasticizers, and we were successful in doing that, one of which was really rather elegant. And I was talking to a few companies, particularly a company in England that was interested in medical tubing for neonatal care units. And then COVID hit, and they all disappeared, and no one cared anymore. So we switched gears towards looking at ways to break down post-consumer PVC, which I think is a bigger problem. Like, we can use other plastics for medical tubing, although they're still using PVC a lot. But I think the bigger problem facing humankind is the persistent plastics and the use of single-use plastic items.
Yeah, and we're at supposedly over 470 million tons of plastic produced every year. And of course, about half of that is single-use plastics, which would not include PVC, correct?
No, it can include
Oh,
PVC.
it can? Okay.
Yeah.
What kind of single-use products have PVC in them? Too many to name, maybe.
Probably, yeah. They used to use it a lot in food packaging, and I think they've backed off on that. But there's just so many items that we have that are made out of PVC that I don't even, everything from sports equipment to clothing to furnishings and things around your house and parts of, the tiles and the window frame surfaces and things like that.
Yeah. So,
anything called vinyl is
right.
PVC.
Okay, including like vinyl siding or...
And records.
Vinyl records or
yes.
vinyl seat covers or...
Mm-hmm.
Yeah.
Right.
Wow, okay. Because I always tend to think of it in the stiffer form, the white.
Yeah, so that's called rigid PVC, and it doesn't have as much plasticizer or has almost no plasticizer in it. And then everything that's somewhat flexible has more and more plasticizer. It can be up to 60% by weight plasticizer.
Wow.
Yeah.
Okay. Wow. So this is probably too technical a question for most of our listeners, but I'm curious how, if you've got, multiple compounds together, I basically assume, I know because I've, done work in factories and I've been to a PVC pipe factory, for example, they're extruding essentially a sort of waxy melted bunch of PVC into these molds that it comes out as pipe, When you mix and you've got all these other plasticizers in there, are they bound together molecularly, or is it just kind of in solution and then it hardens?
It's what it's called is it's in the polymer matrix, so it's actually not bound to anything, and so particularly plasticizers tend to migrate out of the PVC object with time. And so if you've ever had, for example, a plastic flower pot and you put it outside and a couple years later you go to pick it up and it breaks.
Yeah, it becomes brittle.
It becomes brittle because the plasticizers have migrated out of them. Wow. And so where is out? Out is into the environment. It's going into the soil. It's going into your hands. It's going, and it's not disappearing. It's just going out to the surface and then, going into the environment. Wow. And so, it's a huge problem.
Yeah, and this, I know from what little reading I've done on the subject that that endocrine disrupting compounds are affecting, of course, human beings because we use plastic products, but it's affecting all kinds of creatures. And is it only mammals that are affected, or what's its impact overall?
I don't know beyond mammals because I'm not a biologist, so this is beyond my expertise, but I know that there's a species of, I think it's like an otter or something in England, and they were becoming extinct because of the endocrine disruptors in their waterways.
Yeah, and they're being blamed for declining fertility among not only humans, but also domesticated animals, including, cattle and such. So... and of course, these are, let us say they are suspicions, perhaps not absolutely known, but this is stuff that there's a lot of evidence for.
Some of it, they actually know exactly what it's doing on a biochemical level. It's beyond my expertise, but I've seen, seminars where people are studying exactly what the phthalates are turning into biochemically, being metabolized into, which are causing the endocrine disruption.
Right. For any listeners who may have just tuned in, my guest is Rebecca Braslau. She is a professor of chemistry at UC Santa Cruz, and she has been leading research on material science projects, particularly around persistent plastics in the environment, developing methodologies to deal with post-consumer waste PVC. So you're looking at how to upcycle these materials after use. When you say upcycle, you're obviously talking about transforming the material to something useful again, right? So how would you approach that for something like PVC?
Right. So right now my lab is focusing on polybutadiene and polyisoprene, two simpler, much more easily handled polymers. And so we're actually converting these to small organic molecules that could be used as feedstocks for the chemistry industry, whether it's pharmaceuticals or new building materials or anything else. And these are traditionally things that are harvested from petroleum products. So if we can take old rubber or old polybutadiene and turn that into chemicals that we don't need to get from petroleum, that would be a great use of reusing the carbon atoms that are locked into the plastic.
Interesting. Well, and you mentioned tires. Tires is also a huge waste disposal problem globally, and the rubbery portion of tires is all made from fossil fuels, essentially, right?
I think it's all made from fossil fuels, but it's no longer all made from rubber. So
right.
It's now a block copolymer or types of block copolymers. But there is a company that actually is starting to desulfurize or cross-link old tires and reuse them. I think they're based in Canada. And so there is some, and they actually have a pilot plant that's pretty large. So there are some promising things happening in the world of tires. And tires are complex because it's usually polystyrene, polybutadiene copolymer or block copolymer. But at least it looks like there may be a solution for old tires coming down the pipeline.
Good. Yeah, I would love to see that become universal.
Yeah.
I've been around outside the U.S. around waste dumps where they were being burned.
Another huge really problem is tire wear particles, because as your tires get older, the little bits of tire wear off and end up on the side of the roadside and in the waterways and the soil. And it's not like they just evaporate and disappear somewhere. The tire wear particles are a huge environmental hazard that we're just starting to really understand.
Yeah, huge contributor to microplastics. Yeah. As you're doing this work, you clearly have a purpose in mind. You're trying to rectify a situation where we're essentially creating a lot of things that are hazardous to our health, to the health of the environment, and we need to deal with that before it becomes so critical that it's too late, I guess I could say. So I wondered if you could talk about, you're coming from the perspective of very specialized knowledge, and you can analyze the products where you're dealing with in terms of their chemical composition, and you can look at their interaction with other chemical compounds. And to me, that seems like, almost an endless mystery. Like you're having to try many different things, but you're coming from a perspective of understanding how those molecular bonds work, which ones are likely to react, which ones are not. So from that perspective, you mentioned some very hopeful things, some hopeful developments. What do you think it will take to get those early stages of good things, good ways to deal with this, to a level where it's being done, all across the industry?
That's a hard question to answer. I think instead of really thinking about how scientists can solve this for us, is what we really need to do is stop using so much single-use plastic. I mean, that to me, we still have a lot of multi-use plastic that gets used, and I think what we really need to do is to cherish the polymers that we have and reuse them and collect them, isolate them, sort them, and reuse them as best we can. But we have to just really stop using single-use plastics. And if you walk into almost any of the grocery stores anywhere, including here in Santa Cruz, almost everything is wrapped in plastic. And we can't afford to do that anymore because there isn't a perfect way to fix that. There's some biodegradable plastics, and there's some that have been greenwashed to make people think they're biodegradable. There's some that are actually just hitting the market now, polyhydroxyalkanates, which are much more biodegradable than the polylactic acid products that people have said are compostable and really can only be composted in industrial composters at very stringent conditions. So we can move in that direction, but we need to just stop using single-use plastics. That's, I think, how are we going to make my research turn into something that will fix things? I don't know that it ever will fix everything. We're trying to make a tiny little dent, but I think that society has to change our behavior.
Mm-hmm. Yeah, and I like to reflect on in the 50s. I was born in the early 50s, and I got to see visit stores where we didn't have any plastic. We did our shopping without it. We did a lot of things without plastic, and certainly there are some things that we've gotten technologically since then that I think are great. But I can't say that the plastics actually improved our quality of life, particularly in most cases. They may have reduced the cost of products, but they haven't materially affected our quality of life in any other way. And it seems that just creating sort of a different culture around how we store, transport, and present product, for sale would be not that complicated, but it needs support, financially, politically, and from people saying, we want this, right?
I think that plastics have improved our lives tremendously. If you look at the medical industry, we don't worry about, contamination, high-performance sports materials. Our cars are lighter weight than they used to be because of plastics. So I think plastics really have, but the problem is, the easy problem to fix, I think, is the single-use convenience plastics. That's what we need to get away from.
Yeah.
And keep the high-performance plastics and the medical plastics, keep what we can that's really valuable to us, and treasure those things and reuse them, recycle them, rather than just putting them in the trash.
Yeah, and single-use plastics apparently comprise about half of the total waste stream. So that's a lot. That would be a huge impact to get rid of half of it. And then the other half, your group is working on a very specific project dealing with PVC. Are there other researchers that you're aware of working on other aspects of dealing with plastics?
Absolutely. There's people who've worked on polyethylene terephthalate and what the best way is to break it down and actually turn it back into the original little teeny tiny molecule called a monomer that is then polymerized to make a, quote, polymer. And they've had great success in that, and there's actually some plants that are starting to do that. Polystyrene is another one that people have been able to break down back to styrene and can then repolymerize to make new material that's just as clean as what they call virgin plastic that comes from clean monomer.
That's amazing.
So there's a lot of people looking at a lot of different types of plastics, and there's other people also working on the PVC problem as well.
Mm-hmm. Yeah. So there's an effort. I mean, you could call it a global effort. I'm sure it spans other countries. Is it being supported? I assume you're dependent to some extent on grants?
Yes, so the National Science Foundation's supporting my research and supports a number of other research groups doing similar type things. And there are also a lot of chemists who are now envisioning brand new polymers that have cleavable linkages designed into them so that one can, in the future, make the polymer and then break it down to clean little fragments and then reformulate them back to high quality new plastics. But that's still far in the future. The research is happening now, but nothing's been turned into a commercial entity yet.
Right. Wow. Okay. So that in many ways is hopeful news, but it doesn't obviously solve our current predicament with plastics. And there has been some legislation that creates some manufacturer responsibility, as they call it, extended producer responsibility, and that seems to be moving in the right direction.
Right. So California's SB 54 is this extended producer responsibility legislation, and it kicked in January 1st, there was a ban on polystyrene foam clamshell food packaging in the state of California. And there's a bunch of deadlines coming up in 2032 to reduce single-use packaging. And it's really shifting the financial burden of collecting, recycling the plastics back to the producers rather than relying just on the consumers to do so. And I just want to mention that a number of other states like Maine and Oregon, Colorado, Maryland, and Minnesota also have these extended producer responsibility laws. And France has been doing it since 1992 and Chile since 2016. So there are some steps forward in this. But I think that the producers for so long have just done whatever they want and said, okay, it's the consumer's problem to deal with this afterwards.
Yeah. Okay. Well, I'm glad it's starting to transform. Well, we just have a couple minutes left, so I want to invite you to tell listeners how they might learn more if they'd like to, and anything else you'd like to say about sort of the state of plastics and about your work that you'd like our listeners to know.
Yeah, I think that we need to be much more careful about what we're willing to buy in terms of using our commercial buying power to minimize, for example, buying mushrooms that are in styrofoam packaging as opposed to cardboard. Really easy choice. Just get the cardboard stuff and lobby your favorite grocery store to stop carrying styrofoam packaging for mushrooms, for example, or anything else. A lot of people don't know that the clamshell packaging that is used for like berries and things like that in the grocery store is not recyclable in the city of Santa Cruz because we have a very small manufacturing recovery facility, and it is recyclable at some other places, but just small things like that make a big difference. And we can't just assume that because there's a nice recycling bin that we can just throw it, quote, away and it'll get taken care of. Right now, a lot of things get landfilled because we don't have a huge facility in Santa Cruz. And I encourage people to tour the recycling facility at Dimeo Lane. They have a great program, and they'll teach you how to recycle properly and make you more aware of what can and can't be done. That's something I really encourage people to do. I also my father was an aerospace engineer, and he always believed that science would just solve everything. Science is not going to be able to fix this. We have to change our behavior. We also need to fund science, obviously, if we want innovations, but I think we really need to change our behavior as consumers.
Yeah. Well, Rebecca Braslau, thank you so much for coming on the program, and thank you so much for your work.
It's a pleasure to talk to you, and I hope that people listening will understand that they can't just wait for the scientists to fix it all.
Thank you much.